Hi everyone, this is Jonathan Berry from Accelatis. Thanks for joining our presentation on remote performance monitoring. We can get started now. Everyone should see up in the left-hand corner of my screen, we have a little tool that we're using to help us guide our time, so it just shows how much time we have left for the presentation. And given that it's a shorter format, we'll move along quickly and keep kind of the background to a minimum to get into the details. And after the fact, please send any questions you have. If we have time at the end, I'll answer them. Otherwise, we'll definitely get back to you after the presentation. So today we're going to be talking about remote performance monitoring and what it means in the context of Accelatis. So first, we just give a little bit of background on Accelatis if you're not familiar with who we are and what we do. And then we'll talk about what it means to do remote performance monitoring, how we can use it to help identify and solve problems in your Hyperion environments. So the first thing, I think everyone should know that Accelatis is a software company. We are not a consulting company. Sometimes when we do presentations and have discussions, people get the impression that we do consulting as well. And that's not the case. We work with several partners who do that sort of work in implementations and migrations and who leverage our software along the way. But Accelatis is focused on building and supporting commercial quality application performance management solutions. A little bit of background on myself. Again, this is Jonathan Berry, former director of the Hyperion Financial Management Development Team, actually one of the original creators of the product. Our team is comprised of former Hyperion developers and technologists with combined over 50 years experience, so we're uniquely suited to be doing what we're doing. And also on the line we have Ed DeLisi, who was formerly from Hyperion as well as ran North American sales for Upstream, and then Finit before joining Accelatis earlier this year. So what does Accelatis do? So if we can break it down as simply as possible, it's about knowing, predicting, and then acting. So when it comes to knowing, it's all about monitoring and understanding what's happening in your environment and providing key insight and quantifiable information regarding performance of the system. We also provide user simulations and load generation capabilities that allow you to do capacity planning as well as determine performance of the system before environments are rolled out to the user base. And then ultimately it's acting. So once you have this key information, being able to leverage it and use the ad hoc tools that we have in our solution to get the information you need when you need it. What we're talking about today is remote clients in particular, which is part of the monitoring aspect of the software. And again, monitoring is one part of application performance management. So what is remote performance monitoring? And we'll discuss it in the context of how Accelatis solves the problem. So the first thing is it's about tracking user experience from remote locations. And the key word here is user experience. So all the KPIs and metrics and detailed analysis of memory and bandwidth really don't mean a whole lot unless we're talking about it in the context of user experience. So Accelatis focuses on user simulations to really understand what users are experiencing from their locations. And this can be everything from logging in to running reports to running SmartView or even planning forms. It's all about how are they using the system and what performance that they are seeing. Secondly, we have to provide that data in a meaningful format. So that information has to come across the admin so that they can readily use it and make sense of it to make insightful decisions going forward. And then along the way, what we want to do is have enough controls in place that we can allow the admins to quickly distinguish between something that's Hyperion related to something that might be hardware or network related. So providing capabilities to quickly drill in and make a distinction whether it's one or the other. And this can help in a number of ways. In addition to helping to pinpoint where a problem is, the ability to rule a whole aspect of the system out as an issue can be equally valuable. And then provide automated alerting. So all these things are great for doing ad hoc analysis, but even better if they can be running in the background and alert whenever issues are detected. And when we talk about issues, we really talk about it in two ways. One is a failure, meaning a network is down or something is not responding properly, like workspace, or something more like a soft failure where it's still returning but it's taking so long to come back that ultimately the end user is going to pick up the phone and call the hotline. So we look at these as hard and soft failures. Excuse me. The challenges we have with remote performance monitoring, this is in the context of Accelatis or really any enterprise solution, is that there's so many different factors at work that will play into what our users experience. The first is that there's all sorts of different technologies. There's different technology stacks, everything from the database to application servers to web servers to networks to routers and load balancers, as well as, especially in the Hyperion world, there's many different protocols that are being leveraged along the way. Secondly, getting into the user view of the world is that different users have different expectations. So a report that might seem acceptable to someone coming in at 6 or 7 seconds might be unacceptable to someone else. So aside from detecting problems, being able to baseline performance at different locations to provide a set of quantifiable user expectations is of great value as well and can save a great amount of time for someone working in the help desk line when someone calls in and says that something's acting slowly. Being able to quantify not only what they're experiencing, but whether what they're experiencing is normal or not is very important. And then, of course, it comes into the support side of things. So if a user picks up the phone and calls a finance admin or help desk person about a problem, oftentimes many different groups and people need to get involved to solve the problem. So getting quantifiable information very quickly in one place is really key. So what are the goals of doing all this? First of all, it's to, as we said, quantify what the users are experiencing and then baseline it. Again, all about understanding for certain what users are seeing and being able to set expectations and not rely on second-hand or third-hand information. Then in terms of solving the problem, it's all about isolating technology, so being able to rule things in or out. And this comes either within the Hyperion environment as well as external layers, whether it's hardware, database, or network. And most importantly, know about the issues before the users do. So it's one thing to be able to help a user on a call determine what the problem is, but even better if the problems can be predicted and that they can be identified before most of the users experience the issues so that they can be addressed proactively. Okay. And I didn't do a good job of keeping up with my little tool on the left, but we will going forward. So we've covered the background, a little bit of the challenges and what our goals are. So now we're going to discuss how Accelatis helps solve the problem. So we'll discuss technically how it gets deployed, what it actually does underneath the covers, and then we'll actually go through a few scenarios at the end. So the very first thing is Accelatis employs the use of what we call remote performance clients. So at the bottom of our screen we have the Hyperion environment. So this is going to be your S-base planning, HFM reports, and so on, including all your web servers and WebLogic and IIS, running either in a data center or at some location, maybe even a hosted environment. And then at external locations, and these might be locations which are in the building next door to the data center, they might be across the country or halfway around the world, are where users are located. And it might be a small office or it might be a large location. In any case, remote performance agents can be deployed at these sites, and a remote performance agent is basically a very small piece of software that runs in the background, takes up very little resources, but is connected to the Accelatis agents in the Hyperion environment and can receive commands and then execute various tasks and then save their results back. So the first job is to deploy the agents, which is effectively running the agent on a server. And what I have here depicted are various types of servers. It could be generally what we want are machines that are always on, whether it's a mail server, some other support utility server, or even a file server. Ultimately, they can run on an actual end-user machine. The issue with that is when the user closes the laptop to go home, we're not going to be receiving data. So it depends on how acute the issue is. But the first goal is just to deploy the remote performance agents. And once they're deployed, They're all managed centrally, so they never have to be touched again, on site. The second step is that the agents get remotely instructed from the core Excelus user interface, and they can be instructed to perform any number of tests. Generally, what we do at almost every remote performance client is to have them run various network tests, things like pings and trace routes, so that we can collect information that is focused purely on the network. So it basically takes Hyperion out of the picture, and we can isolate what's happening on the network, both in response time as well as details in terms of how the calls are getting routed through the network. Other things we can do are basic things like URL probing, so basically knowing how long it takes to bring back a particular web page, and this could be something like the workspace main page or planning or HFM. So now we're bringing a little bit of Hyperion into the picture by just ensuring that the connectivity to the web servers is functioning and that getting some basic response times to core web pages. We can then do more detailed tests, which are really going to execute at a very deep level in Hyperion by running full synthetic transactions. So part of the Excelus Ascension Suite solution is our user simulations functionality, and this includes pre-packaged user simulations. So these are full synthetic transactions for Hyperion, and these include everything from financial reports to planning forms and rules, as well as Smart View through planning, interactive reporting, as well as HFM Smart View and HFM. So basically all the key tasks that users will perform via the web have all been pre-recorded and factored so that they can be used pretty much right out of the box. And the remote performance clients can be instructed to execute these simulations all from the central console. So it might be that every 5 or 10 minutes pings and trace routes are done, and every 15 or 20 minutes full synthetic transactions are executed. And what this does is it captures network activity and performance. It then captures some very basic high-level performance of URL probing, and then it captures a deeper full synthetic transaction where, for example, a financial report preview does everything from logging into Workspace, navigating to a report, opening the report and refreshing it, and logging out. So it's really exercising everything from the web server down to the database. So all these actions are performed on a regular basis in the background, and then ultimately the agents will then submit their results back to Excelus. So all the performance times and results for pings and trace routes and URL probing, as well as the full synthetic transactions are returned. And what that allows is you, when you're running the Excelus console, to now do all sorts of trending analysis on performance from different locations. So I mentioned before about setting performance expectations, and it's very possible that users in, let's say, London may have much better average response times than users in Tokyo, and that could be for a number of reasons. But just knowing that the average response time for some benchmark report is 5 seconds in one location, and that exact same report from another location, users can expect, double or triple the performance. That's important to know just for handling users' expectations. So all these results come back to Excelus and are saved, and then what we can do is we can alert on them and report on them and do all sorts of different processing. And in addition to automated processing, as I said, the data is available for reports and trending, so you can go back in time and see how performance improves or degrades based on other activity in the system, whether it's a monthly close or some other simulated activity. But ultimately, Excelus can send out alerts. So if thresholds are set, so if there's ever any connectivity errors or any infrastructure errors, alerts can be sent out, or help desk tickets can be created, or some other email or other notifications can be processed. It can also detect if performance is below a certain threshold. So even if the tests are successful, if performance is below a defined threshold, then alerts can be sent out as well. And the goal there is to identify that performance has degraded to a point where you know that users are going to start picking up the phone and calling a help desk, and then identifying it and being able to jump in and address it before the majority of users find the problem. Okay. So the last step, we're going to talk about how to use some of this data to analyze and come to some conclusions. The examples that we're going to do are all based on looking at performance graphs, which can be a little bit technical, but when you have a little bit of training on understanding what it's looking at, it should become very obvious how to read them. This is one example of how Excelus helps solve the problem. Other cases which we don't have time to do in this format are to look at how within the Excelus user interface you can drill down from a very high level view of the world, even looking at a world map of specific locations, and being able to drill in on a potential issue and to get more data on what exactly is failing. And then being able to drill into that even further and see the history of that particular health check, when it failed, when it succeeded, and having information such as ping information and trace route right at your fingertips, so that there is this wealth of quantifiable information that can then be used to collaborate among different groups, finance and IT and hardware and networking folks, to come to a decision on how the problem should be investigated. The examples we're going to use here, again, there's 3 core examples which we'll use, and they're all based on performance graphs. And what we're looking at is, over the course of 5 hours, various performance data. And if we look over here on the left, I've color-coded what we're actually looking at, and you can think about this as a technology stack. So in this case, we're looking at this blue line is database performance. So how is the database responding to simple queries? So obviously that is at the foundation of everything in Hyperion, so that if there is an issue with the database, obviously many other things along the way are going to get slow and possibly fail. So knowing that our database is functioning is very important. The green line is performance of a benchmark task. In this case, it was a consolidation. And within Excelus, any automated type of activity or simulation can be defined as a benchmark task, so that it can be executed in the background and then tracked over time, so that if we're trying to track down an issue, we can review our various benchmark task performance and make a determination whether a problem is systemic, meaning it's affecting everything, or whether it's isolated. So that if we know a particular type operation always takes between 5 and 7 seconds, for example, if that operation is taking 20 or 30 seconds, well, we know that there is something very fundamental happening in the environment. Whereas if that task is taking within the range that we expect, then some determination can be made that at least some things in the system are working properly and that it is not a system-wide issue. And then moving up the list, in this case we're really talking about web response. So we have system response. What is meant by that is a web request as if it were made by sitting right on top of the web server. So if you were sitting right at the web server and you entered in whether it's a user simulation or a URL probe, what is the response time if you're right on the server? So you're basically eliminating many aspects of the network, taking it right out of the equation. So that's another sort of benchmark test. The next one, the purple line, is a local response. And what we mean by this is if you have a user base that is located in proximity to the data center, so these are folks on a LAN, what is their performance? And that is something that can incorporate now everything going on with the infrastructure as well as the LAN, but removing aspects like the WAN. We're then including things like the network ping. So from our remote locations are these the light brown and the dark brown lines. So what is our network response time as well as what our user response time is. So for the first example, and we'll move through these quickly, we see that about 2/3 of the way through our performance tracking, we see that the user experience has degraded significantly by about 50%. So what conclusion could we make by looking at this graph? And I'll jump to the answer in a second, but by seeing that all of our benchmarks and all of our other local performance are stable, and seeing that our network ping has not changed, the conclusion the initial conclusion we'd make, and there's other information that needs to be reviewed, is that the problem may be at the remote location. But just knowing that there were no perceived issues in the network, that we can start ruling that out as a potential problem, because our ping time, and we could drill into this and look at our trace route as well. Because that is not an issue, we can start looking at something that's more local to that user. Okay. Another example where all the other lines are the same, except now our network ping jumped in line with our user experience. Or what I should say is that our user experience follows a network drop in performance. From this case, because if we were sitting on the server, our performance is good, or if we were sitting at that local site, our performance is good. From this, we may make the quick conclusion that there's a problem with the network. So this is something where if you were looking at this example, you might not jump into looking at the Hyperion infrastructure, because if you were sitting locally, Hyperion is still responding as we would expect. In this case, it looks like there's something going on with the network. And our last example, we could see that our user experience is still poor from that remote location, but our network ping is stable. Well, look at this. Our system response and our local response have degraded in line. So a remote user is seeing the same thing in proportion that our local users are experiencing. From this graph, the conclusion that we would come to is that there's something in the Hyperion infrastructure that's amiss, because it doesn't matter whether you're in Tokyo or whether you're sitting right on top of the server, something has happened to performance. So in this case, you could very quickly say, no, we don't really need to involve our network infrastructure people. We can jump right into Hyperion. So the point of all these examples are to, by looking at the performance at the different layers, and you can quickly rule certain aspects in or out of the equation, and you can start focusing on the core problem. Again, in this format of 21 minutes, these were some 3 quick examples, but I wanted to show how, by collecting this information and just having a little bit of insight in how to read the graphs, we can make some quick determinations and really cut through our mean time to recovery of how much time we spend addressing issues. So with that, and again, we move pretty quickly, I just want to point out that coming up, come see us at Kscope. There's several presentations focused on Accelatis, some given by us and given by our partners at Mindstream, as well as some in conjunction with a client. So with that, if you do have any questions, please send them to us. We'd also appreciate any feedback with regard to our 21-minute format. Again, the goal of this was to not take up your whole lunch hour, but provide something that's very quick and digestible. So hopefully you got a lot of value out of this. And again, let us know if you have any questions. Otherwise, thank you all for joining.